Hi, in this video we're going to talk about execution plan cache. Now, the first thing that we probably want to be aware of is why would SQL Server even want to cache the execution plan? Wouldn't it always be better just to create a new plan and therefore always make sure that the best execution plan is used every time a query is running? And to answer that question, the first thing is SQL Server doesn't create the best execution plan, it creates a good enough plan, keeping in mind the time that it will take to finish executing the query as well as the amount of resources that will be required to do the job. So while most of the time the plan looks like as if it's probably the best plan, there is really no guarantee that it is the best plan. So then we come to the situation about why would SQL Server cache the plan in the first place? And that is because the execution plan that SQL creates whenever it runs a query is not something that's very lightweight. It's something that takes a lot of effort and resources to come up with. For simple queries, the execution plan can be arrived at somewhat quickly. But as the query becomes more complex, as the number of joins and the type of aggregations and the operations that happen to the data increase, you'll see that the execution plan also proportionally gets more complex and consumes more resources to arrive at. So because of the effort that SQL Server will take to arrive at the execution plan, it makes sense for us to save a copy of the plan just in case the query gets executed a second time around. And that's kind of what plan cache is about, because it makes sense that if there is something complex that you have to do, you want to go ahead and remember how you did it last time, just so that you can reduce the number of steps that you'll have to perform, or the number of effort that you'll have to do to stop, think, and understand how to proceed to the next step. So the best way to understand this is to actually do an example. So that's what we're going to do next. So let's go ahead and do that. I've got a query here, and when you install SQL Server by default, the settings look somewhat like this. So there is a property called optimize for ad hoc workload, which I'm going to set to 0. And the database is usually in parametrization mode simple. So now that we have those two, what I'm going to do is I'm going to free the procedure cache so that there is no execution plan available in the memory at the moment. And I'm going to run a fairly simple query where the departure delay is greater than 100, greater than 66, and greater than 11. Now, for all intents and purposes, this is the exact same query, and the only difference is the hard-coded value of 100, 66, and 11. But because this query is fairly simple, what SQL Server does is it does simple parameterization and substitutes or replaces the hard-code values that I created with the input variable. So if you look over here, what SQL Server has done in this particular query is taken my hard-coded value and replaced it with a variable called at1, and then defined that variable on the top and just passed the values. This way, the body of the procedure or the body of the query doesn't change, and therefore SQL Server knows that this is pretty much the same query that was run previously. And this is simple execution or simple parameterization for you. However, notice what happens when the query becomes somewhat complex. So again, here I've got a query, it's doing a join, it's got a group by and an order by, and a number of things. I'm going to go ahead and flush the procedure cache one more time, and I'm going to run this query. Again, departure delay is 100. The next query is exactly the same except for the departure delay being 66, and the last one being 11. So for most of the logic of the query, you'll see that we're still fetching roughly the same type of data. And the only thing that's changing in this particular case is the departure delay value. However, this is a slightly complex query as far as SQL Server is concerned, and therefore you'll notice that SQL Server comes up with 3 different execution plans and doesn't perform the parameterization that we saw before. You'll see that there is no variable defined at the beginning. So this is considered bad for us, mainly because we know for a fact that this is the exact same query, and the only thing changing in this query is just the value for the departure delay. However, because the body of the procedure or the logic has changed, the body of the query has changed, SQL Server has to assume that this is a different query, and therefore it comes up with a new execution plan which it then uses only once. And this is problematic only because of the fact that you'll see here the size of these execution plans are not nominal. They actually consume a decent amount of size. And if we go ahead and then have another query with say 1, 2, 3, 4, every new value of departure delay is going to result in a new row in the execution plan, and these memory that it's consuming is going to add up, And pretty soon we're going to have memory issues just because of the plan cache eating up all the memory, storing plans that get used only once. The solution to this kind of problem is actually to go ahead and create a store procedure. And that's something that I encourage a lot of people to do, that if you have these kind of issues, what you should be doing is you should always try and see how you can create a store procedure. But a lot of the time it's not practical, simply because you're probably inheriting a database and there is an application that's already having all this code written into it, or you're using some kind of ORM tool. So a lot of the time the flexibility is not afforded to you where you can convert or rewrite the code, but if that option is available, that's what you should be doing. So you can see here in this case what I've done is I've gone ahead and manually specified the variable and converted that whole logic into a parameterized query, which is basically nothing but a store procedure. Another way you could do this is by running sp execute SQL, which is also binding parameters to the query, so it treats the logic like as if it is a procedure. So the idea being, when I was doing simple parameterization way up here, I was relying on SQL Server to go ahead and substitute this value with an input variable. But because the query became complex, we find that SQL Server doesn't do it for bigger queries, and now I'm forced to do it myself by creating a store procedure and defining the variable. All right, so let's go ahead and create the procedure and free the procedure cache. And now I'm running the exact same query, except I'm changing the input parameter. And when I do that, because this is a query, this is a stored procedure, the execution plan is being persisted inside SQL Server because it knows by the name of the procedure that this is code that has been executed previously. And you'll see that we have the one single execution plan available here of type procedure, which is compiled, and it's been used 3 times. And this is one way that you want to handle plan caching, where SQL Server is reusing the execution plan because you have removed any hard-coded values within the string. The other option available to you is to set optimize for ad hoc workloads equal 1. And what this means is, when the query is being executed the first time, SQL Server will create the execution plan, but it doesn't save the execution plan in memory. And therefore, what happens is the query will run with the execution plan that was generated on the fly, but it doesn't consume memory unnecessarily. Now that's for the first time that query runs. The second time the query runs, SQL Server will actually understand that it's created this execution plan previously. It'll look at the plan stub. It's kind of like a placeholder for the execution plan, and understand that I've run this query before, and since it's come up again, I'm assuming this is a query that runs pretty frequently. So the second time around, SQL Server will actually save the execution plan. So let's have a look at how that works. I'm going to flush out the procedure cache, and you'll see that what I've got is I've got my Texas over here, and you'll see that I've got 66 and I've got 11, just like before. But see the amount of memory that this particular plan is using now. So you'll see that because it's a complex query, SQL Server cannot do parameterization, so that's fine, but it's only creating a plan stub. If you look over here, the type is ad hoc, and it's creating a plan stub. But more importantly, look at how the execution plan isn't really being persisted, and therefore we only use 448 bytes compared to the I think like 91 kilobytes, I guess, from the previous execution. So this is good for us, because what's happening in this particular case is SQL Server is understanding that this particular execution plan has already been executed once, or it hasn't been executed before, and it doesn't look like it's a stored procedure, so it doesn't seem likely it'll be called again, and therefore it's not going to waste memory trying to save the execution plan for a query that's going to be run only once. And that's ad hoc plan optimization for you, or optimize for ad hoc plans. So I'm going to undo that, because the next option that's available to you is to set forced parameterization. Now, if you remember, right up on top we did simple parameterization, where SQL Server expected that if the query is simple, SQL Server is just going to go ahead and substitute the hard-coded values with parameters. Now I'm going to force SQL Server to go ahead and do that particular operation, not just for simple queries, but even for complex queries. And I'm going to do that by setting the parameterization is equal to force. Once again, I'm going to flush the procedure cache, and once again I'm going to run the ad hoc queries. Only this time you'll see that even though the query is complex, and even though the values are changing, we end up with just the one execution plan Let me go ahead and show you that real quick. And if you look here, we've got the one execution plan created, which has been used 3 times. And this time around, SQL Server has gone ahead and basically just rewritten the query the way that we were expecting it to. So the parameter that was changing was the delay date, departure delay, and that's why that's been substituted as a variable over here on top. And that's pretty much it as far as parameter caching or plan caching is concerned. So basically, plan caching in itself is a very simple concept. It's just about SQL Server saving an execution plan in memory on the off chance it'll need it later. The problem that happens is people confuse all the different ways that plan caching can occur. You can have it as a simple parameterization, a forced parameterization as a store procedure, maybe recompilations happening within a store procedure, maybe it's optimized for ad hoc workloads. So there are a number of different settings that will affect the way that the plans are being saved. Sometimes it's saved in the first attempt, sometimes it's saved only after the second attempt, sometimes it's never saved at all. And that's where people tend to get confused in terms of when does SQL Server exactly save the plan in memory and what are the chances that it will be reused once it's there. And hopefully this video will clarify that for you. And I hope you understand the differences between parameterization simple versus parameterization forced, the impact of rewriting a query as a store procedure, and how the store procedures plan gets saved in memory, and therefore store procedures only encounter compile in the first time when they're being called. And these are the kind of small things that usually people miss out. And obviously this is a follow-up to the video that I did previously about parameter sniffing and how page splits and defragmentation, etc. occur. So I hope you found this video useful, and thank you for watching.